The reference folder for triangle guts. For triangle guts, we're going to be going through 4 interior triangle segments as well as their points of intersection, also known as triangle centers. So a median of a triangle, so let's just identify what is a median. A median connects vertex to a midpoint. So draw a little sketch and eyeball what looks like a midpoint. Hatch mark, that's a midpoint. A median is going to connect from vertex to the midpoint. That's a median. The medians of a triangle intersect at the centroid. Now, because the median connects vertex to midpoint, the construction we're going to do is the midpoint construction. We're going to do 2 of them because they have to intersect with the medians. So we're going to first find the midpoint of this side. You open up your compass just past what looks like the middle. And this is a sweep point. Just past what looks like the middle. So that's about the middle right there. Just past, plant your pivot. It's a tilt drag motion, a tilt twirl. So it's a big sweep. Go to the other side. Do not change the compass setting. Sweep. You get your straight edge. You identify where these 2 points of intersection, use your straight edge, find your exact midpoint. Hatch mark, that's a midpoint. Now we're going to do the midpoint of another side. And do the midpoint going this way. Plant your pivot on a corner, open up just past what looks like the middle. It's sweep point. So sweep, tilt and twirl. Sweep, tilt and twirl. Two points of intersection, line them up with a straight edge, and you have yourself an exact midpoint. Now, connecting vertex to midpoint, vertex to the opposite midpoint, that's a median. Vertex to opposite midpoint, that's another median. Where they intersect is called a centroid. And the vertex to the centroid. So vertex to centroid is twice as long as a centroid to midpoint. So this is twice as long as this. You want to mark it. This is a 1 bunny hop and 2 bunny hop situation. It's a 1 piece to 2 piece, equal pieces, of course, of relationship. Now we're going to do the ortho center. An altitude goes from the vertex to a right angle on the opposite side. Take a little sketch. Vertex, right angle, opposite side. That's an altitude. Doesn't go to the middle. It just hits the opposite side at a right angle, which means you have to do a perpendicular line from an outside point. When you have multiple altitudes, those altitudes intersect at the orthocenter. So we're going to draw a perpendicular bisector to, not a perpendicular bisector, just a perpendicular segment to this pink line. This is a smiley dimple dimple. We're going to do it from this vertex point. We're going to make a perpendicular. You open up your compass so that you're just past the opposite side. Plant your pivot. You're going to do a smiley. Just a hair past the opposite side. Smiley. Now look carefully. There's going to be 2 points of intersection at the smiley. Those are what I call the dimples. Now notice I'm flying off the page. It's okay to shorten your compass base here, but do not change your compass settings between the dimples. So I'm going to shorten this up. Smiley, plant, dimple, dimple. Must use a straight edge. Straight edge is longer than mine is. Don't break the rules. But that hits at a perfect right angle. Smiley, dimple, dimple. Next one, I'm going to do an altitude. It doesn't matter which way I could have done this side. I'm just going to go over this way. Smiley, dimple, dimple. Just slightly past the opposite side. Sweep a smiley. Two points of intersection. Once again, I go off the page, so I'm going to choke it up, like choking up a bat, making it shorter. Do not change your compass settings between the dimples. So, dimple, dimple, smiley, dimple, dimple. You can connect those 2 points of intersection. The altitude, and that's an altitude. This point of intersection is called the orthocenter. A perpendicular bisector is a segment which is both perpendicular and bisects a segment. Looky there, it's named by exactly what it does. In a triangle, a perpendicular bisector is a segment that bisects a side, which means it goes through the midpoint, and is perpendicular, which means and it makes a right angle. It does not necessarily go through the vertex. So your eyeballs are not on the vertex, your eyeballs are on the side. It is right angle to the side and bisects. The perpendicular bisectors intersect at the circumcenter. This is a fun one, or at least I think it's fun. We're going to do the perpendicular bisector of This side. It's the same construction as a midpoint. It's a sweep, sweep segment. Open up just past what looks like the middle. I have a sweep and a sweep, 2 points of intersection. That is a midpoint, hatch marks. Perpendicular bisector. Perpendicular bisector. Now I'm going to also bisect this side. Past what you think the middle is. Two points of intersection. Line them up. This is a perpendicular bisector, and they cross at the circumcenter. Now, how do you test it to be the circumcenter? The circumcenter means the center of the triangle that allows you to draw a circle around the triangle. So plant your pivot on the circumcenter and your drawing point on any one of the three corners. It's easier to twirl the paper here. If you've done this accurately, you are going to have a circle drawn through all three corners, spot on. That's why it's called circumcenter. Circum means around. It's the circle around the triangle. An angle bisector cuts a corner angle in half. So when I have a triangle, if I have this angle here, the angle bisector cuts that angle in half. You're cutting the angle in half, not the side in half. Angle bisectors of a triangle intersect at what's called the incenter. An angle bisector is a smiley, dimple, dimple. Smiley, dimple, dimple. So I'm going to bisect this corner right there. Is it? Smiley. Hatch marks. Angle bisector. I'm going to do another one on this side. Smiley. I've got 2 points of intersection, right here and right here. I'll list the dimples, dimple. Dimple. Sure you correctly spot that point of intersection. double hatch. This is also an angle bisector. And they meet at what is called the incenter. Now, take your compass and put your pivot at the incenter. And put your compass setting so that it meets at a right angle to the side. So just kind of visualize it. You wanted to see it going at a right angle. You want it to be spot on that side. Here. Then fold from the center and roll the paper. Done this correctly, you're going to have a circle inscribed. That means drawn inside with the circle touching the inside of the triangle at 3, what we call tangent points. Inscribed. That is the in center of a triangle.